ain't got a good brain.
I think you've got a fine brain, Jack.
You make me happy.
Cause I'm an idiot asshole, talking further from my gas hole.
All right, enough of that. Let's get started. So I had an opportunity to speak with some no-ballers about their thoughts on gravity, and I think I've gotten to the bottom of where their malfunction is on this whole Einstein theory, Newton law. And I'm not going to refer to Newton as anything other than law, because it's Newton's law of gravitation. And I think I can explain why Newton is law. Newton will always be law. Newton's not going anywhere, and neither is gravity. This fake conflict that they think they've manufactured here is just that. It's manufactured in their heads. It happens on the no-baller, circle jerk forums of stupidity, where the dumbest people on Earth go to hear from the other dumbest people on Earth so that they can reaffirm that, that's right, I'm smart because I'm with all these other smart people that don't know no maths. And yet, if you think that's a misquote or misrepresentation, I got the receipts. Yeah, we ain't got to do no maths to know Earth's flat. No, and on that we can agree. Is people who don't know how to do no maths are going to think the Earth is flat. That's true. But you know absolutely nothing. You can agree on that. That's common ground we share. We ain't got to do no maths. Nobody ever done any calculations that use, there ain't no buoyancy calculations that use gravity. That ain't how, it's just buoyancy. You just need to know the buoyancy. No.
But how does a ship made of steel float while the nail or coin made of the same steel sink? Steel has density higher than that of water. But when it is used to construct a ship, the newly formed vessel structure's average density gets reduced because of the air that occupies the inner portion of the vessel compartment.
Wait for
When
it.
the ship is in water, two forces act upon it. First one is gravitational force due to the ship's own weight, and another one is upward buoyancy force equal to the weight of water displaced by the ship. When the buoyant force is equal to, or more than that of gravitational force, the ship continues to float. When gravitational force exceeds due to events like inflow of water into the compartment, gravitational force exceeds the buoyant force and the ship starts sinking. Same.
So they go into more examples, but all engineers know exactly what this YouTube video said. We don't need the YouTube video to prove it. We don't just hang around on forums and say, oh, gee, that's what we'll go with. That'll be the new mantra. Like no-ballers saying that, well, I don't think jet planes are powered by jet fuel because I saw it on the internet. Or I think that this picture from a beach proves the Earth is flat because I saw it on the internet. No. Flat earthers, no-ballers will repeatedly lecture engineering professors on what it is the engineering professors teach in the classroom without going to the classroom to find out what is being taught. What they teach is, here are how we can use calculations to prove that gravity works. It works in all cases. They have no idea. They can't do 5th grade algebra. They don't know that left side and right side of equations balance out. Therefore, all you need in order to determine there's a force is an acceleration. And if you need to have an acceleration, you get a force. Why am I bringing this up? Let's get back to Einstein and Newton.
Anyway, to sum up, let's show the final results again. In Newton's case, that was derived by considering some forces and equating one force to another one. In Einstein's case, no forces were mentioned at all. The derivation went completely through some geometric considerations, like world lines, 4 velocities, and imposing some conditions, such as the normalization condition for 4 velocities or the geodesic equation. And as we can see, the results are almost the same, barring a small correction that appears in the relativistic case, which is usually completely insignificant. And that's even though the calculations themselves were completely different and had almost nothing in common. So that's it. If you made it to here without being scared off by all the maths, hats off to you. I hope that even if not everything was completely clear, I managed to at least provide a window into how general relativity works under the hood, and what the calculations in that theory look like.
give credit where credit's due. Go check out Science It Out. So important here is because Newton wrote 3 laws, the third law is that for every force there's an equal and opposite force. One would assume from that, and that's really where his F of gravity is coming from. But to Einstein, we have an inertial force acting on the object. In Einstein's view, this is, remember, Newton is law, Einstein is theory. The frame of the surface is accelerating upwards, so there will be an inertial force acting downwards on the object. Total F is non-zero, i.e. a felt force. This is every actual scientist's interpretation of Einstein. Einstein never said that if you put a weight on a bridge, the bridge won't feel. The forces said, no, it's just buoyancy and density. No, force. Force is still apparent in Einstein. We'll get into how this is all true. Total F is non-zero and A is also non-zero, the acceleration. So in both Einstein and Newton's view, there is a force acting on a falling object in the reference frame of Earth's surface. I'm going to super simplify Einstein for those that either aren't understanding or you're a no-baller or you're not getting it. Einstein is saying that the bending of space-time is causing matter to move. Super simplified, but that you are being accelerated even though there's no force causing it. Nonetheless, your feet on the scale will measure a force. The pain you feel in your feet for standing too long, that's a force. Einstein is not denying the existence of a force, and Einstein existing, and Einstein's equations existing, and Einstein's descriptions existing do not debunk Newton, in that the second half of the equation of m times a equals f, or m times g equals f. Weight is still felt, weight is a force. Weight is treated as a force. Simplifying it even further from his description. His description is not inaccurate. It's probably still too complicated for the no-ballers. Newton would call it the force of gravity. Einstein would call it an inertial force arising from the acceleration of the reference frame in curved spacetime. But whatever you call it, it is there and it's exactly the same force. We have Science It Out explaining it to people who are actually curious about science, and then I'm explaining it for the no-ballers because they're morons. So Newton's laws are still valid, but often the forces accelerate objects will turn out to be inertial forces in this description. I'm ignoring the part he put in red. He highlights it. I'm thinking that's not crucial to this video. We'll get into other things later on. But purpose of this description here that I'm giving is physicists agree, science agrees, that Einstein and Newton are actually in agreement on the important parts of weight, force felt by gravity. It's still there. We're going to go into explicit detail as to why engineering accepts Newton's laws as law, and that will never change. And Einstein's theory, or whatever the final law, once some universal theory of everything becomes a universal law of everything, irrelevant. Gravity will be included. Newton's laws will be accounted for in them. They will say, in your reference frame, where there is no major distortion of space-time, and you can approximate to Newton, you approximate to Newton. By the way, when we're talking about the distortion of space-time, we're talking about tiny little thousandths of degrees, 100 million miles away. The example that Einstein sought to correct. Whitsitt, who absolutely does not get it, keep springing up saying that this is somehow a heliocentric assumption. No, it's the question that needs answering, but the answer does not debunk anything within our reference frame. Einstein leaves that door open. In your reference frame, and it's covered right here. In your reference frame, the frame of the object that is inertial. So we're talking third paragraph here. The frame of the object that is inertial. So in your reference frame, where you're experiencing no relativistic contraction because the distances are not great enough, Newton's law is spot on accurate. When you start talking about 100 million mile distances, distance from Earth to Mercury, that's the distance where you start noticing thousands of degree wobbles in where you would expect Mercury to be over the course of 100 years. It's minuscule, and not only that, no-ballers don't even believe this conversation ever happened because they don't believe in space or Mercury. They think they're just twinkly lights on the ceiling. Using this as a defense or an excuse, because you know what they're going to do anyway. They're going to say, oh, see, Einstein with that tiny little wobble in Mercury that's 100 million miles away in space. Yeah, that theory, it totally debunks Newton's law. Okay, so let's go with relativity. We don't believe in space anyway. That's not true either. So they're going to pit one against the other, even though they don't believe in the actual data that Einstein is presenting. They're going to pit Einstein against Newton, even though they don't believe in the data of Einstein.
They're at war with gravity because somehow or another they think that if we can rename gravity to unicorn farts, that's a real, actual quote from several. It's now traveled through the flat earth or through the no-ball or circle jerk forums of stupidity, and multiple independent no-ballers that haven't even talked to each other. It's like spread like a virus. They are now talking, well, let's just rename it unicorn farts because that's just as logical. It's like gravity's just the name. The observation is still there. It's real. It's not going anywhere. So these people are just being morons by trying reducto ad absurdum. It's like, well, if we rename it unicorn farts, then see how silly it is? Like, yeah, you're being very silly. No question there. Witsit and some of the other Discord server morons have presented that postulate before as, well, we could just rename it. Now, you could. It doesn't matter. We can tell that mass attracts mass. So mass is attracting mass, and the only thing that no-ballers have in their defense now, that we've got this advanced scientific equipment, is nuh-uh. But we'll just go through basics, but we're just simplifying this. The basics of engineering, and why there's no reason to discount Newton literally ever. It will always work. The math will always work. It will do you favors when you're actually trying to design things, because the force equals the force. Here's why.
Now, let's just get started on, they're both just theories and they've both been debunked. Nope. Newton's law of universal gravitation is actually undebunkable because it's tested every single day, thousands of times per day. Any place that builds cool shit uses gravity in their calculations, and it is law, and it is undebunkable. It was verified so many times during the 17th and 18th centuries that it was called Newton's law of universal gravitation. Not only are the morons that keep saying, no, it's never been tested, gravity's never been tested. No, it was tested so many times and never debunked that it's called Newton's universal law of gravitation. The only place this question is the circle jerk, no baller, moron forums. That's the only place. Physics is not concerned.
No, you just need to know the density. You don't need no gravity. You just
shh. No. It's okay. Tell us where the gravity touched you. It'll be okay. No. How do they calibrate precisely and know precisely what the force is on this hydraulic piston, and that they can trust the gauges that they put on these joints, on these I-beams, are accurate, and they're telling them that a certain amount of force will break this. And this works for a bridge too. This doesn't have to be an excavator arm. Just multiply the size of this thing and they do bridges the exact same way. Everywhere that's doing engineering, bridge engineering, excavator engineering, bulldozer engineering, ship engineering, aircraft engineering, all of it, they're going to use gravity. When you put a weight in a big piece of equipment that you need to know how much weight it can carry, how much strength is needed in the hydraulic piston, how much strength is needed in the girder. Let's treat this as an I-beam. You can put a tension gauge. They actually have gauges that can measure the microscopic twist and contortion, the stretch of the top of the I-beam versus the stretch of the compression of the lower I-beam, which can tell you how much force is on the I-beam and how close it is to structural failure. And they are calibrated precisely, as in when, in this case, here's a picture of, say, a case excavator. They know exactly what the force is on that I-beam. They know exactly what the force is on that hydraulic piston. To test how much strain is happening on the metal, which is measured in newtons per meter squared, actually. If you go to a steel supplier or titanium supplier or aluminum supplier, they measure things in newtons per meter squared because Newton is the metric system, i.e. the SI, the most commonly used measurement system in the world, on the globe. They use newtons for weight and force. Weight and force. Why is that? Here's why. You put a weight in the bucket to measure the strain on the girders or on the hydraulics, and you can match that precisely with a force gauge on a winch. You could put a winch on that bucket and winch it down, and when you get to, say, let's just pick a small number for a little toy excavator or something like that, okay? 98 newtons, 10 kilograms. You put 10 kilograms in a bucket of your little toy excavator, and it has the exact same effect on the girders, on the hydraulic piston, as a winch pulling at 98 newtons of force. A force equals the weight. The weight equals the force. That happens every day, everywhere, always. That's why it's Newton's law. You want another example? Aircraft engine on a test bench. Do you know what that force coming out of that engine is equivalent to? The winch with the force gauge and the engine pushing that much force are exactly the same. Let's put this engine on an aircraft while going straight up. If the aircraft weighs 18,000 newtons and the engine produces 18,000 newtons of thrust, that aircraft can maintain and or accelerate going straight up. But that's the point, is weird. Newtons counter thrust can counter weight. It's called a thrust to weight ratio. It's how maneuverable aircraft are actually measured on their ability to outclimb their competitors. Planes like the F-16, the F-18, the F-15, the Su-27, the MiG-29, the Eurofighter, the Rafale, F-22 Raptor, they are judged on their thrust to weight ratio. Let's see, what is weight equivalent to? A thrust in newtons. Force. Newton is a measure of force. So an aircraft able to outclimb, its weight is using force. Weight is treated as a force in physics. That's Newton's law. Okay? Happens every day. Flat Earth Circle Jerk forums want to pretend like it never happens. They declare to actual engineers, physicists, and mathematicians, that ain't never no happen. That they don't use no calculations. You don't need no calculations. You just need no density. You just need no buoyancy. False. That's not how this happens. They precisely calculate how much thrust they need to beat their competition. They precisely calculate how much strength they need in the girders to beat a certain amount of weight without structural deflection, whether it be the arms of an excavator or a bridge. They do this. They measure using gravity. Force equals mass times gravity. Newton said with every action there is an equal and opposite reaction, which therefore Newton says F equals m times g equals F. Einstein said you have too many F's in the equation. Both Newton and Einstein agree. The bucket feels a force, and they have two mildly, very, very mildly different explanations for this. Newton says, well, if you feel a force, you must have a force. There must be an equal and opposite reaction. Einstein said, if something were being pushed by a force, you wouldn't see this tiny little wobble 100 million miles away in Mercury. So instead, I'm saying that it's the acceleration of space-time bending, g, that is causing m times g equals F. We just eliminate that portion of the equation, and you still have Newton's equation in there. These are equivalencies. In physics, there's nothing wrong with equivalency. M times G equals F, and it's the same as F equals M times G equals F. Everything on every side of the equal sign, if you have followed your units correctly, is still correct. Every single time you use weight, it is felt like a force. That's why. So that happens every single day on every bridge, on every boat, on every aircraft, on every train, on every excavator. Every day. There's engineers doing that calculation to make sure that their structure can match the weight. They can handle the weight. It's not accidental. It's not just, you just need no buoyancy. Just put some buoyancy. All right, they make everything out of styrofoam if that were the case. No. You don't just need no buoyancy. They don't do no calculation. You don't know the shape of the earth. You don't know how physics works. You don't know what engineers are doing every day. Happens when you confront them. It's like, no, it's been tested all the time. Engineers do math every day. The no-ballers will then, with their cognitive dissonance, go to the distance and say, engineers don't do no math. That's what they'll do. It's that dumb. They're that dumb. So this is the great controversy. So every time you're confronted by a no-baller, it means that there ain't no gravity, and there never was, because I don't think so. It doesn't matter. Just, you can show them this video. If you can't explain it in your own words, you just show them this video. And the next time they bring it up, just show them this video. And the next time they bring it up, just show them this video. It will never change. Not in any of our lifetimes will Newton ever go away. And gravity will never be debunked because it's there. Really. The thing that Newton noticed and called gravity is absolutely there. You can just go to any place that builds excavators, bridges, planes, trains, boats, and say, hey, if you were to put weight on something, and then you were to compare that to putting force on a force gauge, would you see the same thing? Yeah, you would. Ah, I see. So gravity exists. Gravity reproduces the effects of force. Newton and Einstein have different sentences that describe that. Neither one of them debunks gravity. Neither one of them are obsolete. We can use Newtonian gravity literally for all time, and it will always be there. It's not going anywhere. You've done nothing. You've wasted your life. Cheers.